Picture a world that defies our earthly imagination, a realm where volcanoes soar to heights 3 times greater than Mount Everest, where canyons stretch vast enough to span the entire length of Brazil, and where ancient waters may have once harbored the secrets of life itself. This extraordinary world isn't a figment of science fiction. It's our cosmic neighbor Mars, a planet that holds some of the most spectacular geological formations in our entire solar system. Today, we're embarking on an extraordinary journey to unravel the geological mysteries of the Red Planet. Our exploration will take us to Olympus Mons, the mightiest volcano ever discovered in our cosmic neighborhood. Standing as a testament to Mars' violent volcanic past, we'll venture through the breathtaking Valles Marineris, a canyon system so vast it would stretch from New York to California if placed on Earth. Our journey will also reveal compelling evidence of Mars' watery past, where ancient rivers and lakes once flowed freely across its now dusty surface. Finally, we'll examine the groundbreaking discoveries from recent Mars missions, including Perseverance and Curiosity, which continue to reshape our understanding of this enigmatic world. Before we delve deeper into the Martian depths, let me welcome you to Exploring the Universe, your premier destination for cosmic discoveries. Just as Mars reveals its history through fascinating geological layers, our channel offers layers upon layers of captivating content about the cosmos. Think of each episode as a core sample, drilling deep into the mysteries of space, revealing new wonders with every exploration. Together, we'll uncover the secrets hidden beneath the red sands of Mars, understanding not just its past, but perhaps glimpsing into Earth's own future and our place in the cosmic story. Join me as we traverse Martian landscapes that challenge our understanding of planetary geology, explore ancient riverbeds that might have once hosted primitive life, and witness the raw power of planetary forces that have shaped this alien world. Mars isn't just another planet in our solar system, it's a geological wonderland that continues to captivate scientists and dreamers alike, offering us a unique window into the evolution of rocky worlds and the potential for life beyond Earth. Picture a mountain so colossal that its base would cover the entire state of Arizona. This isn't science fiction. This is Olympus Mons, the largest known volcano in our solar system. Standing at an awe-inspiring height of nearly 22 kilometers, it dwarfs Mount Everest and every other mountain in our cosmic neighborhood. To truly grasp its magnitude, imagine standing at its base. The slope would be so gentle and the volcano so vast that you wouldn't even realize you were on a mountain at all. The curvature of Mars would hide its summit from view. What makes such a behemoth possible? The answer lies in the fascinating geology of Mars, which tells a story dramatically different from Earth's. Unlike our geologically active home planet, Mars lacks active plate tectonics. On Earth, continental plates are in constant motion, sliding and colliding, which prevents volcanoes from growing beyond certain limits, as the moving crust eventually carries them away from their magma sources. But Mars plays by different rules. On the Red Planet, when a volcanic hotspot forms, it remains fixed in place for millions, even billions of years. This geological stability creates what scientists call a point source volcano. Imagine a cosmic game of patience. Layer upon layer of lava flows, gradually building up over immense periods, each eruption adding to the volcano's height and girth. Without plate movement to interrupt this process, Olympus Mons grew to its current astronomical proportions over approximately 2 billion years of accumulated volcanic activity. The Martian environment itself contributed to this extraordinary growth. Mars's gravity is only about 38% of Earth's, meaning volcanic materials could pile higher before collapsing under their own weight. Additionally, the lack of substantial erosion from wind and water helped preserve these massive structures. While Earth's mountains are constantly worn down by weather and erosion, Mars volcanoes have remained relatively unchanged for millions of years. The sheer scale of Olympus Mons challenges our earthbound perspectives. Its caldera, The crater at its summit is complex and composed of overlapping circular depressions, each one created by separate volcanic events. These collapsed craters span an area roughly 80 kilometers across, large enough to swallow many Earth cities whole. The volcano's slopes are marked by channels and ridges carved by ancient lava flows, telling the tale of countless eruptions that shaped this geological marvel. Around the base of Olympus Mons lies another fascinating feature, a cliff or escarpment that in some places reaches heights of up to 6 kilometers. This dramatic edge formed as the immense weight of the volcano caused the Martian crust to bend and crack, creating a stunning natural wall that encircles much of the volcano's base. This feature, combined with the volcano's other characteristics, helps scientists understand not just Mars' volcanic history, but also the planet's internal structure and evolution. Understanding Olympus Mons and Mars' volcanic history is crucial for unraveling the planet's past potential for habitability. These ancient volcanic processes would have released vast amounts of gases and water vapor into the Martian atmosphere, potentially creating conditions more favorable for life during the planet's early history. Even today, the rocks and minerals formed by this volcanic activity could preserve evidence of ancient microbial life if it ever existed on Mars. If you've ever stood at the rim of the Grand Canyon and felt overwhelmed by its vastness, prepare to have your mind completely blown by Mars' Valles Marineris. This mammoth canyon system is nature's grandest carving in our solar system, a scar so massive on the face of Mars that it would stretch across the entire United States if placed on Earth. We're talking about a canyon system that extends over 4,000 kilometers long, reaches depths of up to 7 kilometers, and spans up to 200 kilometers wide. To put this into perspective, if you were standing on one rim of Valles Marineris, you wouldn't be able to see the opposite side, not because of dust or atmospheric conditions, but simply because the canyon is so impossibly wide that the other edge lies beyond Mars' horizon. This makes the Grand Canyon, impressive as it is, look like a mere crack in comparison. While the Grand Canyon could fit comfortably within one of Valles Marineris' side canyons, the Martian canyon system itself would stretch from Los Angeles to New York City if superimposed on North America. The origin of this colossal feature remains one of planetary geology's most intriguing mysteries. Unlike the Grand Canyon, which was primarily carved by the persistent flow of the Colorado River over millions of years, Valles Marineris appears to have a more complex birth story. Scientists believe it likely formed through a combination of processes, each contributing to its current magnificent state. One leading theory suggests that the canyon began as a massive crack in Mars' crust during a period of intense volcanic activity in the nearby Tharsis region. As this volcanic province swelled with magma beneath the surface, it caused the surrounding crust to bulge and eventually split apart, creating the initial rift that would become Valles Marineris. Think of it like the cracks that form in a cake as it rises, but on a planetary scale. The story doesn't end there. Over billions of years, this initial rift appears to have been modified by multiple geological processes. There's evidence of groundwater erosion, landslides of epic proportions, and possibly even glacial activity. The canyon's walls show distinct layers of rock, much like pages in a book, revealing different episodes in Mars' geological history. Some of these layers contain minerals that could only have formed in the presence of water, hinting at a much wetter past. Particularly fascinating are the massive landslides that have occurred within the canyon system. Some of these rival the size of small states, with debris fields stretching dozens of kilometers. These landslides have helped widen the canyon and create the dramatic scenery we see today. The evidence suggests that some of these events might be relatively recent in geological terms, indicating that Valles Marineris is still an actively evolving feature. Deep within the canyon's recesses, scientists have identified what appear to be water-carved valleys and alluvial fans, suggesting that water once flowed through parts of the system. Some researchers even propose that portions of Valles Marineris might have once contained lakes or seas. The discovery of water-related minerals like hematite and sulfates in the canyon's depths supports this hypothesis and makes Valles Marineris a prime target in the search for evidence of past life on Mars. Modern orbital observations have revealed seasonal changes within the canyon, including possible water ice clouds that form in its depths and mysterious dark streaks that appear on some slopes during warmer seasons. These features suggest that, despite its current dry appearance, Valles Marineris remains a dynamically active system, continuing to evolve and change even today. Understanding the formation and evolution of Valles Marineris isn't just about satisfying our curiosity. It's crucial for understanding Mars' geological history, climate changes, and potential for past or present microbial life. Each new mission to Mars reveals more details about this magnificent canyon system, adding new chapters to its already epic story. The rocks of Mars tell an extraordinary tale of a planet that was once very different from the cold, dusty world we see today. Billions of years ago, liquid water didn't just exist on Mars. It was abundant, flowing across the surface in rivers, collecting in lakes, and possibly even filling entire oceans in the planet's northern hemisphere. This isn't science fiction. It's a story written in stone, waiting to be read by our robotic explorers. The evidence for Mars' watery past is compelling and multifaceted. Our rovers, particularly Curiosity and Perseverance, have been like geological detectives, examining rocks layer by layer, each stratum revealing new chapters in Mars' history. These machines, working millions of miles from home, have discovered sedimentary rocks that could only have formed in the presence of water, sandstones and mudstones that preserve ancient river deltas, lake beds, and even ripple marks from ancient streams. Perhaps most exciting are the mineral signatures that scream water was here. Curiosity's investigations in Gale Crater have revealed clay minerals that only form in wet conditions, while Perseverance, exploring Jezero Crater, has found minerals like carbonates and hydrated silicates that require water for their formation. These minerals are like chemical fossils, preserving evidence of water-rock interactions that occurred billions of years ago. The Jezero Crater site is particularly revealing. It contains a magnificently preserved river delta where water once carried sediments into an ancient lake. The layered rocks here are arranged in patterns identical to river deltas on Earth, complete with the characteristic fan-shaped deposit where the river met the lake. Perseverance's sophisticated instruments have confirmed that many of these rocks contain minerals that were altered by water, some of which could have preserved signs of ancient microbial life if it ever existed. But it's not just about standing water in lakes and seas. Mars' surface is carved with networks of valleys that bear striking resemblances to river systems on Earth. These channels, some small and delicate, others vast and profound, suggest that water once flowed across Mars in quantities sufficient to erode solid rock. The patterns of these valley networks indicate they were formed by rainfall and surface runoff, implying that Mars once had a hydrological cycle similar to Earth's. The timing of this wet period is crucial to understanding Mars' history. Most evidence points to the majority of water activity occurring during the Noachian and Hesperian periods, roughly 3.7 to 3 billion years ago. This coincides with a time when Mars' atmosphere was thicker and the planet could have been warm enough to maintain liquid water on its surface. This period is of particular interest because it overlaps with the time when life was emerging on Earth. The chemical composition of these water-altered rocks tells us even more about ancient Mars. They indicate that the water was often neutral to alkaline pH, similar to Earth's lakes and rivers, and contained dissolved minerals that could have supported microbial life. Some locations show evidence of hot springs and hydrothermal systems, environments that on Earth are teeming with microbial life. Even today, water hasn't completely abandoned Mars. It exists frozen in the polar ice caps and potentially in underground glaciers at mid-latitudes. Recent observations suggest that liquid water might occasionally flow on Mars' surface, creating mysterious features called recurring slope lineae, dark streaks that appear and disappear seasonally on certain steep slopes. Understanding Mars' watery past is more than just planetary history. It's crucial for future exploration and the search for life beyond Earth. These ancient waterways and lakebeds are prime targets for future missions, particularly those seeking evidence of past life. The minerals and sediments deposited in these once wet environments could have preserved biosignatures, chemical or physical signs of ancient life, if any existed. The story of water on Mars reminds us that planets can undergo dramatic changes. From a world with flowing rivers and standing lakes to today's frozen desert, Mars stands as both a warning and an opportunity, a chance to understand how planets evolve and what factors contribute to their habitability. As our missions continue to explore the Red Planet, each new discovery adds another page to this remarkable story written in stone. Mars, despite decades of scientific scrutiny, remains a planet of enigmas. Just when we think we've begun to understand this alien world, new observations reveal puzzling phenomena that challenge our existing theories and spark fresh debates within the scientific community. These contemporary Martian mysteries aren't just fascinating, they're reshaping our understanding of the Red Planet in real time. One of the most intriguing puzzles involves the recurring slope lineae, dark streaks that mysteriously appear and disappear on Martian slopes with the changing seasons. First spotted by NASA's Mars Reconnaissance Orbiter, these features seem to flow downhill during warmer periods and fade away during colder times. While initially thought to be caused by flowing liquid water, recent theories suggest they might result from dry avalanches or unique Martian processes involving salts and atmospheric water. The true nature of these seasonal changes remains hotly debated among planetary scientists. Beneath Mars's polar ice caps lies another tantalizing mystery. Radar observations have suggested the presence of underground lakes, particularly a large body of liquid water under the South Polar ice cap. This discovery, if confirmed, would be revolutionary. Liquid water existing today on Mars, preserved by high concentrations of salts and the pressure of the overlying ice. However, some scientists propose alternative explanations, suggesting the radar signatures might be created by layers of frozen clay or other minerals. The debate continues, highlighting how much we still have to learn about Mars's current state. The Martian atmosphere presents its own set of puzzles. Perhaps most baffling is the presence of methane, detected both by Mars orbiters and by the Curiosity rover. On Earth, methane is primarily produced by biological processes, though it can also have geological origins. On Mars, the methane appears and disappears much faster than current atmospheric models can explain, suggesting either unknown chemical processes or possibly even current biological activity. The source of this methane remains one of Mars' most intriguing, unsolved mysteries. Equally puzzling are the various unexplained geological features scattered across the Martian surface. The planet's poles, for instance, show bizarre spiral patterns that seem to be carved into the ice caps, their formation mechanism still not fully understood. In other regions, scientists have discovered strange networks of raised ridges that don't match any known geological process, and perfectly circular pits that appear to be unlike typical impact craters. Recent observations have also revealed unexpected seismic activity on Mars. NASA's InSight lander has detected hundreds of Mars quakes, some of which appear to originate from regions with no visible geological features that might explain them. These quakes suggest that Mars, long thought to be geologically dead, may still harbor some internal activity, though its nature and extent remain unclear. Another contemporary mystery involves the Martian moons, Phobos and Deimos. While long thought to be captured asteroids, their nearly circular orbits suggest they might have formed from debris ejected during a massive impact with Mars. Recent analysis of their composition and orbital mechanics has only deepened the mystery of their origin, leading to new theories about their formation and evolution. The distribution of subsurface ice on Mars presents yet another puzzle. While we know ice exists beneath the surface, its exact distribution and depth vary in ways we don't fully understand. Some regions show evidence of massive ice deposits just below the surface, while other, seemingly similar areas appear to be ice-free. Understanding these patterns is crucial for future exploration and potential human missions to Mars. Perhaps one of the most perplexing current mysteries involves the planet's magnetic field. While Mars no longer has a global magnetic field like Earth's, it retains patches of strong magnetic fields in its crust. These magnetic anomalies are much stronger than scientists would expect, and their patterns suggest a complex magnetic history that we're still trying to decipher. These ongoing mysteries make Mars an exciting target for continued exploration. Each new mission to the Red Planet has the potential to solve some of these puzzles while inevitably discovering new ones. The combination of advanced technology and careful scientific investigation continues to reveal Mars as a complex world that, even after decades of study, still has many secrets to share. Understanding these current mysteries isn't just about satisfying scientific curiosity. It's crucial for planning future missions, especially potential human exploration of Mars. Each solved puzzle brings us closer to understanding this alien world that may one day become humanity's second home. The study of Mars geology represents far more than an academic exercise in understanding distant rocks and formations. It serves as a powerful mirror, reflecting both our planet's possible past and potential future. Each layer of Martian soil we analyze, every mineral we discover, and all the geological features we map are pieces of a cosmic puzzle that could help us understand not only Mars' history, but also Earth's potential fate. The Red Planet's geology tells a story of dramatic planetary change, from a warm, wet world with conditions potentially suitable for life to the cold, dry desert we see today. This transformation holds crucial lessons for Earth as we face our own climate challenges. Mars stands as both a warning and a laboratory, showing us how a planet's climate can change dramatically and helping us understand the delicate balance that maintains Earth's habitability. Perhaps most thrillingly, Mars's geology offers tantalizing clues in humanity's quest to answer one of our most profound questions: are we alone in the universe? The preserved records of ancient rivers, lakes, and possibly even oceans, combined with the discovery of organic molecules and methane in the Martian atmosphere, suggest that if life ever existed beyond Earth, Mars would have been a prime candidate to host it. The fact that we can read these geological records billions of years after they were written gives us hope that if life did exist on Mars, we might still find evidence of it preserved in the planet's rocks. Each new mission to Mars, equipped with increasingly sophisticated technology, peels back another layer of the planet's mysteries. From the towering peak of Olympus Mons to the depths of Valles Marineris, from the ancient riverbeds to the polar ice caps, Mars's geology continues to surprise and inspire us. These discoveries are not just expanding our knowledge of the Red Planet, they're helping us plan for humanity's next great adventure, the eventual human exploration and possible settlement of Mars. The methodical study of Martian geology is also preparing us for an even grander quest: the search for life on distant exoplanets. The techniques we develop to understand Mars' past habitability and to search for biosignatures in its rocks are helping us develop the tools and expertise we'll need to study worlds far beyond our solar system. Indeed, every rock analyzed by our rovers, every image captured by our orbiters, and every measurement taken by our instruments brings us closer to answering fundamental questions about our place in the cosmos. Mars's geology is a testament to the dynamic nature of planets and their potential to harbor life, reminding us that we are part of a larger cosmic story, one that we are only beginning to understand. As we conclude this exploration of Martian geology, we stand at the threshold of a new era in planetary science. Future missions will continue to unlock the secrets hidden in Mars' ancient rocks, while advances in technology will allow us to explore places we can currently only observe from afar. The study of Mars geology isn't just about understanding another planet, it's about understanding our own origins, our potential future, and our place in the universe. Join us on our next adventure as we turn our gaze to an even more extreme geological wonder, the incredibly active volcanoes of Jupiter's moon Io. There, we'll witness geological processes that make even Mars' massive Olympus Mons seem tame by comparison. We'll explore a world where the gravitational forces of Jupiter create such intense internal heating that Io's surface is constantly being reshaped by volcanic activity, making it the most geologically active body in our solar system. Don't miss this opportunity to continue our journey of discovery through the most fascinating geological wonders our cosmic neighborhood has to offer. Together, we'll continue to push the boundaries of human knowledge, one geological discovery at a time, as we unravel the mysteries of our solar system and beyond. The story of Mars's geology is far from complete, and each new chapter brings us closer to understanding not just the red planet, but our own place in the cosmic story.